You know, every single day, right under our feet, there's this incredible transformation going on. It's the hidden journey of wastewater sludge. It's a process that is so critical that without it, our cities would pretty much grind to a halt. So let's follow that journey, from the very beginning to the very end.
It all kicks off with a bit of a riddle. What's something that is 99% water, but at the same time is a huge, expensive problem for literally every city on the planet?
The answer? It's raw wastewater sludge. That's right. The very thing we need to dispose of is almost entirely just water. The whole challenge, the entire point of this incredible journey we're about to take, is to figure out how to separate a tiny fraction of solids from a massive, massive volume of liquid.
So what exactly is this stuff anyway? Well, wastewater sludge is simply the mix of water and solids that gets separated out during treatment. Just think of it as all the gunk that either settles to the bottom or floats to the top inside those giant treatment tanks.
And right away, we hit our first big hurdle, just getting this stuff from point A to point B. As you can see here, it's a real balancing act, kind of like a Goldilocks problem. If you pump too little, you leave solids behind, and that can cause some pretty nasty odors. But if you pump too much, it's way too watery, and you just end up wasting a ton of energy and space. You have to get that flow just right.
So, getting that flow perfect leads us to the first major stage of this journey, thickening. The goal here is simple, but it's a huge one. We need to start the great squeeze, removing a massive amount of water to turn this liquid problem into a slurry that's way more manageable.
And engineers have two main tricks up their sleeves for this. First, you've got the settle method, or gravity thickening. It's exactly what it sounds like. You just let the heavy stuff sink. But for the lighter, fluffier solids, they use the float method, or dissolved air flotation. With this one, they inject millions of tiny air bubbles that basically act like little life vests, attaching to the solids and floating them right to the surface so they can be skimmed off.
So what's the result of all this settling and floating? Well, we've taken a sludge that was barely 1% solid, and we've concentrated it all the way up to about 9% solids. That is a huge step. A massive amount of water is now gone. But believe it or not, our journey is far from over.
Okay, now that the sludge is thickened, it's ready for the final and most powerful squeeze. We call it dewatering. This is where we go from a thick slurry to something that's actually solid enough to pick up. Now, to make this happen, operators add special chemicals called polymers. You can think of them as supermagnets for solids. They cause all the little particles to clump together, which forces out all the water that was trapped between them. And the result is a texture that the source material describes perfectly. It looks just like brown cottage cheese. That cottage cheese then gets fed onto a machine that, honestly, works kind of like a giant industrial pasta maker. It's called a belt filter press. The sludge gets spread on this porous belt, water starts draining out immediately, and then a second belt comes down from the top, creating a little sludge sandwich. This sandwich then gets woven through a whole series of powerful rollers, squeezing out every last possible drop of water until a scraper blade finally removes the solid product at the end.
Of course, there's a more low-tech way to do this: sludge drying beds. You can basically think of them as giant outdoor sandboxes. The sludge is poured on top, water drains through the sand, and the sun and air just do the rest of the work. And as it dries, the source material notes that the surface cracks apart, looking remarkably like a cheesecake.
So we've followed this whole journey, from a watery mess all the way to a solid cake. But what's the point of all this? Let's talk about the payoff and why this process is absolutely critical for every single modern city.
This chart really puts the entire journey into perspective. I mean, look at this. We started with a raw sludge that was only about 1% solid. The thickening process got us up to 6%, but after dewatering, we've hit 25% solids. That means we've concentrated the waste by a factor of 25 just by getting rid of water.
And that concentration, that's the whole point. It means there's way less volume to haul away, which saves an enormous amount of taxpayer money. It means we're protecting public health and our environment. This whole hidden journey, this constant squeezing, is literally what keeps our cities from being completely overwhelmed by their own waste. This leaves us with one final and really fascinating question. We've created this stable, solid cake. It's not a hazardous liquid anymore. So, what's next? After all this work to create it, could this former waste actually become a valuable resource?